Hi, my name is Dan Nugrishel from Chiral Photonics. I'd like to speak to you about multi-core fiber links that increase the amount of information that can be sent over optical fibers. I'll review our Phase 2 SBIR work for NavAir, developing mechanical fiber optic connectors for multi-core fibers. And more broadly, I'll speak about high bandwidth density links made possible by these multi-core fibers. And even more broadly, I'll speak about the emergence of the multi-core fiber ecosystem that makes multi-core fiber use practical for many applications that can benefit from high bandwidth density. So firstly, what are multi-core fibers? On the left, you can see the cross-section of a standard optical fiber, a single core fiber that you might find outside your office on a telephone line or underground. The fiber shown is all glass, both the core and the cladding. Multi-core fibers are similarly a single hair-like all-glass fiber. However, they have multiple cores within a single glass cladding. Shown here are examples of multi-core fibers ranging from 2 to 4 cores and all the way up to 19 cores. Allow me to give a brief introduction to our company, Chiral Photonics, a company that we founded almost 25 years ago in 1999. We are located in Pine Brook in northern New Jersey in the U.S., and we have been developing components for multi-core fiber for over a decade. We are the primary supplier of multi-core fiber fan-outs that enable multi-core fiber to be seamlessly integrated into the ubiquitous single-core infrastructure that is well established worldwide. Even fiber manufacturers cannot fully test their multi-core fiber without fan-outs. In addition to fiber manufacturers, we sell our fan-outs to a variety of users of multi-core fiber. For example, a company making the first commercially available system using 3D shape sensing for minimally invasive surgery. In 2022, we were instrumental in the design and installation of the first MCF link between two buildings in a metro network. 288 4-core fibers in this link provide 1,152 channels. In 2023, we started shipping for production of the first MCF cable after successfully completing Telcordia and submarine certification. We are presently shipping hundreds and ramping to thousands of fan-outs per month. We have a strong history of development of custom and standard products. These include pump signal combiners for low and high power lasers, polarizers, providing linear or circularly polarized light, and harsh environment sensors, such as temperature sensors measuring to 1,000 degrees Celsius. We develop products for the market as well as for individual customers, ranging from commercial customers to defense contractors. We have been fortunate over our history to have been awarded over $6 million in federal funding. One such award is our current Phase 2 with NavAir. The Navy wants a connector for a multi-core fiber. In this case, the solicitation was for 1550 nanometer connector for a 2-core fiber to enable high-fidelity communications, sensing, and surveillance systems. The Navy wants a ceramic ferrule to withstand harsh environments and has these shown performance requirements. The Navy also had this attack system target for deployment. In this solicitation, NavAir acknowledged the slow adoption of fiber optics in military airborne systems. The goal of this solicitation was to help leapfrog the use of this technology into radio frequency over fiber, RF over F, microwave links that can offer high bandwidth density and higher dynamic range capabilities than could otherwise be offered by multiple fiber systems. And because of the higher bandwidth density, systems could be smaller and cables can be lighter and more flexible. We propose to develop these multi-core fiber connectors in 3 formats that are familiar to standard single-core fibers. A physical contact or PC connector, which is a standard connector with a flat polish. An angled connector or APC connector for low back reflection, providing higher dynamic range. And an expanded beam connector, which is a more forgiving connector for harsh environments that see a lot of dust, grime, and particles. In all 3 cases, this connector should be mil-spec ready to serve a variety of military applications. Here is a picture of an assembly developed and delivered to the Naval Research Lab. We actually developed these using a commercially available 4-core fiber, where you can also use, if desired, just 2 of the cores. In the center of the central image, you see the ruggedized mil-spec ready connector. The image on top shows the open connector, and the bottom left image is a close-up of the closed connector. On both ends of the connector is a purple aerospace grade high temperature cable containing the multi-core fiber. On either side of the cable are fan-outs, the small white components bordered in blue or red. These fan-outs break out the multi-core fiber to single-core fibers, 4 single-core fibers on both ends of this assembly. This enables the multi-core fiber link to be seamlessly integrated into any more standard single-core fiber optic network. The Naval Research Lab has successfully tested both the PC and angled connector versions we have provided them. We are currently developing the 3rd variation of this connector, the expanded beam MCF connector. The MCF connectors are based on a widely used shell familiar across the military, the D38999 connector shell. The connectors have exceeded the performance requirements of the grant. Crosstalk has been somewhat limited because the award anticipated use of a commercially available fiber. The commercially available MCF at the time we started was an MCF not designed for low crosstalk. We have worked with a number of multi-core fibers that can readily sustain less than 60 dB of crosstalk, but they were not commercial and not available when we started. However, there's a clear path for lowering the crosstalk from below 52 to below 60 dB using low crosstalk fiber that incorporates a trench design. The NRL also tested these connectors to some higher temperature excursions with no performance degradation. So where do we stand now? We have exceeded the project goals thus far, even delivering on Phase 2 option goals without having the Phase 2 option exercised. Much to our surprise, there is no longer a Navy sponsor. PC and APC connectors have been delivered and are at technology readiness level 4. Expanded beam connectors are expected to be demonstrated and delivered by June 2024 when this project ends. This MCF connector is a nice addition to Chiral Photonics' growing portfolio of MCF components. These connectors expand Chiral's contributions in the growing MCF ecosystem, where we are helping to deliver the first submarine cables incorporating MCF to meet growing bandwidth needs, and where we have been an essential contributor to the first MCF terrestrial deployment, and where we are the primary fan-out provider to the growing 3D shape sensing market. We see that multi-core fiber can play a role in many military applications. In addition to connectors, Chiral has assisted transmitter and receiver developers with MCF fan-outs and related assemblies to support development of the full RF over fiber link. 3D shape sensing, similar to commercial and biomedical applications, can expand situational awareness when applied to towed fiber arrays, for example. Use of MCF can deliver high bandwidth densities to space or weight-constrained applications for swap benefits. MCF can also be used to deliver power over fiber and for surveillance hardening of links. In implementing a myriad of applications, Chiral Photonics is a proven partner that has worked from development through production and installation, and has worked with defense contractors of all sizes. Key features, advantages, and benefits include an MCF connector where none existed. This connector is mil-spec ready and meets or exceeds the Navy's stated specifications in PC and APC versions. The expanded beam version is coming soon. This connector has a familiar form factor. This connector, along with fan-outs and the growing MCF ecosystem, provide access to higher bandwidth density links, higher dynamic range links, and new functionalities such as 3D shape sensing, power over fiber, and surveillance hardening. Importantly, for testing and adoption, these advantages and new functionalities are available with seamless integration into existing networks. Also, MCF offers a clear path to continued scalability with higher core counts. So how do we transition to the fleet? We're looking for a primary transition advocate that can help us identify targets and finalize mil-spec testing requirements, as well as fielded test and demo requirements. This clarity will define ongoing funding needs. Chiral has extensive experience in both in-house and third-party testing for telecordia, submarine, and biomedical applications. We are also a very pragmatic partner. We are open to licensing and OEM arrangements to facilitate accelerated progress and adoption. In parallel, CPI continues to progress on the commercial side. These growing opportunities will help accelerate the transition to the fleet as well as we progress with production scaling and automation, and as we seed new markets, and as we continue with workforce development, market education, and expanded collaborations. A brief overview of the market for multi-core fiber and its use. The submarine cable market carries more than 99% of the world's communication traffic and has an ever-expanding need for bandwidth. This is the market that has driven the development of MCF. The capacities of the ships that lay these cables requires that the cable diameters cannot get larger, so they require higher bandwidth density. Chiral has been supplying R&D and components to this market for the last decade. The first MCF cable is now in production. It is expected to be laid on the ocean floor in 2024 and to become operational in 2025. In the last major submarine cable technology transition to single-core fiber space division multiplexing, or SDM, 70% of the market moved to these new cables within 7 years. A similar transition timeframe is expected for this transition to MCF. However, the biomedical equipment market actually was the first market in the last few years. It beat out the submarine market in adopting this technology. Multi-core fibers with light traveling through multiple cores can sense how the fiber is moving in three-dimensional space. A fiber attached to a minimally invasive instrument can track the motion of that instrument with sub-millimeter precision, guiding biopsies and surgeries. This equipment is already in use, improving surgical outcomes in hospitals and clinics worldwide. Another market, terrestrial MCF links, address high bandwidth density needs and began in 2022. Chiral has also been offering MCF connectorization to its customers for years, mostly using available connectors not optimized for MCF. The mil-spec connector expands these offerings and ties into Chiral's growing defense business, a growing number of specialty components, often relating to space communications. To transition, this product needs a program of record to define the need, to collaborate on defining the needed mil-spec testing, to fund the mil-spec testing, and to define and enable field testing. Several programs that may have diverse interests in multi-core fiber, such as 3D shape sensing and RF over fiber, could collaborate to define next steps that could move forward in parallel. Chiral could work with prime contractors to bring these differentiating multi-core fiber products into their portfolio to enhance their offerings. Again, I am Dan Nugrishel. I would welcome an opportunity to speak to you about your specific application needs. Thank you so much for your time and your interest.